Hello, this is Dr. Lori. We are going to pick up where we left off on the previous video. Um, we were talking about the process of statistical inference and hypothesis testing and discussed a little bit about the kinds of conclusions that we can make. We need to expand now on this whole notion that we could be wrong about our conclusion. So what could possibly go wrong with this inference? So as a quick reminder, we said there are two possible conclusions that we can make. There's no relationship between our two variables, or there is a relationship between those two variables. So let's go ahead and think a little bit more about our hypotheses. There's no relationship between our two variables versus there is a relationship between our two variables. In statistics and number crunching in general, a lot of times what statisticians try to do is they try to create a shorthand way of saying something. So this whole notion of there's no relationship between our two variables, we want to shorten that. And we can say that in a variety of different ways depending on the kind of statistical test that we are going to create, that we're going to test. So if we're going to say there's no relationship between our two variables, if you think about the example that we gave, we had a group of 12-year-olds and we wanted to test whether they were the same average height as everybody who lives in California, then we would say, let's just write it here, the average height of our 12-year-olds from Coachella Valley is 150 centimeters. So in other words, there's no relationship between living in Coachella Valley and how tall you are. If the average height of 12-year-olds who live in Coachella Valley is the same as everywhere else, then that would show that there's not a relationship. Whereas for this same example, if there is a relationship, then we would say that the average height of 12-year-olds in Coachella Valley is not 150 centimeters. They could be taller, they could be shorter, but it's not what we would expect if we were comparing them to what we find in other places. So here we have our two hypotheses that are more specific to that research question, but statisticians want to condense that down even more. And so what they would say here is they would use abbreviations for these. So the average would be mean, and then I'll just say sub HT. Mu sub HT is equal to 150 cm. So really, this abbreviation right here is saying the exact same thing as this is. And it's that also in a broader, more general sense is saying there's no relationship between where you live and how tall you are. So specifically to the Coachella Valley. And so really those three things are all testing the same exact thing. And statisticians want to condense that down even further, and so they call that the hypothesis sub-zero or hypothesis null, the null hypothesis. So all three of those things could be considered to be a null hypothesis. Similarly, we could say, we could condense this down into a much more condensed version. We could say mu sub ht is not equal to 150 centimeters. And so really these three, this is meaning the same thing here. And that means there is a relationship somehow between living in Coachella Valley and how tall these 12-year-olds are. So these three are considered to be the H sub A. Okay, we wanted to say the whole H. Or the alternative hypothesis. Now, an interesting thing happens when we have these two hypotheses. First of all, they are supposed to include all possible options. And so if we have an equal sign, let me get a different color. If we have an equal sign here and a not equal sign here, then that represents everything that could possibly happen with our hypothesis testing. The thing you'll notice is that the equal sign is here in the null hypothesis. Another way of thinking of the null hypothesis is there's nothing going on, there's no difference between my groups, there's no difference between the height of that group and what I would expect it to be. Null, nothing, no, not different, no relationship. Anything that starts with an N is really related to this null, this not different. And so if they're equal, then they're not different. So the equal sign always belongs in the null hypothesis. The alternate hypothesis then is very often it's what we're interested in. It came from that research question. If we go back up here, this question right here, this is what we're wondering about. Are the children who are 12-year-old who live in this specific location, are they a different height? So that is often called the research hypothesis. It can be called the alternative hypothesis or the research hypothesis. So the null hypothesis, however, this is the one that we're assuming to be true. My pen is not writing very well. We're assuming that the null is true, and so that's what we're testing. We're testing whether the null is true. We're testing whether there is no difference. And if we can reject that, if we can say, no, we think that's wrong, then we can conclude that there is a relationship between those two variables. But we're always assuming the null hypothesis to be true, and that's what we're testing. So let me get rid of a little bit of this because now it's in my way. Okay, so there are two. So now coming back around to the what could possibly go wrong, we could make an error, and specifically we're talking about this whole notion of making a random error. We're making a mistake, and it's because of just probabilities related to the hypothesis testing process. So let's say I make an error, and let me back up real quick. Let me say that let me draw this in here. I reject the null. By rejecting the null, what that means is that I take a look here at my null hypothesis. I've performed some test of statistical significance, and if I reject that null, what I'm saying is, no, that can't possibly be right. Or based on the probability that I'm looking at, that can't be right. Then because that is not right, then I conclude that this other thing must be correct. Remember, these are the two possible things, and they are inclusive of all possible outcomes. Either the average height is equal to 150 or the average height is not equal to. If I reject the null, then some people would say I accept the alternate. Now technically that's not correct, because remember, we're always testing the null. We're not testing the alternate. So we can't reject or accept the alternate. But if I reject the null, then my conclusion is that it's reasonable to assume the alternate is correct. If, on the other hand, and I'm going to make an abbreviation here that you'll see a lot, fail to reject, FTR, fail to reject the null. If I do not reject, fail to reject means I did not reject it, or in speaking in non-double negatives, I accept that the null is reasonably correct. Then, and let me see if I can erase this, just this little, and this little one right here. Yeah, okay. So if I fail to reject the null, then what that's telling me is, well, this must be a pretty reasonable thing that I can come to my conclusion. Remember, we're coming to conclusions. If I fail to reject the null, then I say, yep, it's reasonable to assume that the average height of this group in Coachella Valley is equal to 150 centimeters. Now, in both of those situations, either if I fail to reject the null or if I reject the null, in both situations, I could be wrong. I could have made an error. I could have made an error in my thinking, in the whole study. So let's go back to these two conclusions where I either failed to reject or I rejected the null. If I reject the null, then I'm making the conclusion here. If I fail to reject, then I make the conclusion here. But I could be wrong. And each of these has an associated error that goes with it. If I reject the null but I was wrong, that is called a type 1 error. So let me say that again. If I reject the null and I conclude that there is some kind of a relationship between the two variables, but I shouldn't have, that's called a type 1 error. If, on the other hand, I fail to reject the null, and both of these are possibilities, if I fail to reject the null but I was wrong, I should have rejected it, that is called a type 2 error. And those are Roman numerals. We could put a 2 in here if that's easier to see. Type 2 error. And both of those errors come with a probability. Some people would call this a beta error. That's actually technically not correct. Beta is the probability of making a type 2 error. And this is alpha, which is the probability of making a type 1 error. And so if I rejected the null but I shouldn't have, if I was wrong, I can make a type 1 error. And the probability of making a type 1 error is called alpha. If I fail to reject the null but I was wrong, I made an error, that is called a type 2 error. And the probability of making a type 2 error is beta. Now there are some other concepts that go along with this. I'll introduce these to you, but the main thing that I want you to remember is that this is a type 2 error and this is a type 1 error. If we think about alpha as being the probability of making a type 1 error, it's also helpful to think of what is the opposite of a type 1 error. What if I was right? So 1 minus alpha is called confidence. You're going to see this later when we talk about confidence intervals. And 1 minus beta is called power. We will see a lot more of that when we talk about sample size and power. And these are all, there's a lot to remember. And so I want to give you a little sort of mnemonic that one of my students shared with me that I think is really, really helpful. The beta here could be just for a B. And I'm going to put the word here, blind. I'm blind to a relationship that is really there. In other words, I don't have enough power to see that relationship. So beta goes with blind. So I made a mistake. I said there was no relationship, but I'm blind to the relationship that's really there, and probably because I don't have enough power. This little alpha down here looks like a little fish, and so here's the mnemonic that goes with this. The fish lives in the sea, right? I see something that isn't really there. So an alpha error means that I see something, I see a relationship, but it's not really present. So those are the two things that a lot of times can help people remember the difference between those. Remember, a type 1 error is when you reject the null but you shouldn't have, you made a mistake. A type 2 error is when you failed to reject the null hypothesis, but you made a mistake. We should have rejected it. So that summarizes the kinds of errors, what could possibly go wrong in making the conclusions that we make about these null and alternate hypotheses.